Assalamualaikum warahmatullahi wabarakatuh and hi, I am Qurratu Ain Binti Mohd Zaidi and my friends Nur Fazrin Binti Mohd Khairi. Today we are going to explain on our STATISTIC for the pair assessment, and we are excited to talk, and it is actually about problem solving for each question, which involves an experiment of tossing two coins and rolling a die simultaneously. So basically this question is all about understanding probability distribution, independence, and calculating the mean and variance of a new variable. So our goal is explain the solution clearly and concisely so that we will understand more, and we will break it into down step by step using simple language and easy to follow calculation. Okay, so for the first question 1A, construct the joint probability distribution table of x and y. So before we start, firstly we need to define our variables. The first one, x as the total number of hits when we tossing two coins, and y as the number of shown on the rolling die. So we need to determine the possible values of x, which is hit and hit equals to 2 hits, or hit tails equals to 1 hit, and tail equals to no hit. So these outcomes, when tossing two coins, we will get possible outcomes, which is 2 hits, 1 hit, and 0 hit. So each of outcome has an equal probability of 1/4. Beside that, for y, we can know that there is any possibility numbers from 1 to 6. So the outcome has an equal probability of 1/6. For the next question is question 1B. Find the marginal distribution of x and y. So we can calculate by the table. Using this table, for the f1x refers to the sum up of x, and f2y refers to sum up of y. So this is actually similarly, we sum up over all possible values of x for each value of y will lead us to find each of value from 1 to 6, which has equal probabilities based on the contribution from both heads and tails. Besides, the joint probability function must satisfy some of the condition, which is the total sum up must equals to 1. And we will get the answers. So, for the next question is question 1C. Determine whether x and y are independent. So, I will explain on how to determine whether two variables are independent using their joint probability function fxy. Independence between two variables means that their joint probability can be expressed as the product of their marginal probabilities. So, we start by recalling the condition for independence. If fxy equals to f1x multiplied with f2y, where f1x and f2y are the marginal probabilities of x and y, then x and y are independent. So to test this, we will verify the equality at specific points. First, we calculate the joint probability of f01. So which is given as 1/24. So we can compute from the marginal probabilities by multiplying the 1/4 multiplies with 1/6, and we will get 1/24 too. So this condition is satisfied for this pair of values. The next one is verify at point of 1, 4. So we multiply as usual with 1/4 multiply with 1/6, and we will get 1/24 too. So this will confirm that the condition for this pair is equals. So since fxy equals to f1x multiply with f2y, for all tested values, we can conclude that x and y are independent. The next question is question 1D. Determine the mean and variance of W equals to 4x minus 3y plus 5. The first step is to find the mean
which to calculate the expected of x, we can multiply each value of x by its probability, then add them together. The value of x is 0, 1 and 2, and their probabilities are 1/4, 1/2. So after we multiply all of the numbers, and we will get the expected of x is equals to 1. So same goes to expected of y. We multiply each value of y by its probability and add them, and the values of y is 1, 2, 3, 4, 5, and 6. And all have equal probabilities, which is 1/6. And after we multiply all, we will get 7/2. So the third step is to use the formula of ex squared equals to sum up of x squared multiply with f1x. So we will get 3/2, and the expected y squared is equals to 91/6. So now we have the value of expected x and y, so we must to substitute them into the formula of E expected w to get the variance. So we can simplify, and we will get the mean of w is -3/2. After that, we must find the variance of w using this formula of vw equals to 4 square vx plus -3 square vy. And the constant of 5 does not add any variance, so we must ignore. And this means we need to find the vx and the vy. So the first one, to find the vx using this formula, vx equals to ex squared minus ex squared. So vx equals to 3/2 minus 1 square, and we will get the variance of x equals to 1/2. Same goes to variance of y. We will get 35/12. And after that, we use the same formula, and we need to substitute all the answers we get from the variance x and y into the formula of variance w, and we will get 137/4. So that means it is the variance of w.
Next, I will explain how to solve the question 2. Question 2a. Find the value of k. First, the joint probability density function must integrate to 1 over its given limits. I first set up the double integral of f bracket y1, y2 bracket over 0 less than in equal y1 less than and equal 1 and 0 less than and equal y2 less than and equal k. Then, inside the integral, I compute it step by step. First, I integrate f bracket y1, y2 bracket with respect to y1, treating y2 as a constant. Then, I simplify and integrate with respect to y2, leading to k to the power of 2 equal to 1. Solving for k, I found k equal to 1. Question 2b. Find the marginal density functions of y1 and y2. First, we need to find the marginal density of y1. To find it, I integrate the joint probability over all values of y2, which is from 0 to 1. After substituting the function 4y1 to the power of 3 y2 plus y2 and integrating with respect to y2, I simplify and found f1 bracket y1 bracket equals to 2y1 to the power of 3 plus y over 2. Next, we need to find the marginal density of y2. Similarly, to find f2 bracket y2 bracket, I integrate f bracket y1 y2 bracket over all values of y1, which is from 0 to 1. Simplifying the integral, I obtain the function is equal to 2y2. Question 2c. Determine whether y1 and y2 are independent. Two random variables y1 and y2 are independent if the joint density equals the product of their marginal density. Substituting the expression for 4y1 to the power of 3 y2 plus y2 equal to bracket 2y1 to the power of 3 plus 1 over 2 bracket, bracket 2y2 bracket, then we will get the answer. Therefore, y1 and y2 are independent. Question 2D. We are finding the probability that y1 is between 1 over 4 and 1 over 2 given that y2 equal to 1 over 2. Step 1. First, we use the formula for the conditional probability. After substituting y2 equal to 1 over 2, we simplify the equation to 2y1 to the power of 3 plus y1 over 2. Step 2. Next, we calculate the probability by integrating 2y1 to the power of 3 plus 1 over 2 between 1 over 4 and 1 over 2. This involves solving two simple integrals, one for 2y1 to the power of 3 and one for 1 over 2. After adding everything together, the probability is 79 over 512. Question 2e. Find the mean of p equals to 5y1 minus 2y1 plus 8. First, we simplify the formula. We got 5e bracket y1 bracket minus 2e bracket y1 bracket plus 8. Next, so we just need to calculate e bracket y1 bracket. Then to find it, we need to integrate y1 times the probability density of y1. Then after solving the integral, we got e bracket y1 bracket equals to 13 over 20. Then plug this value into the formula. So the mean is 199 over 20.